Okay, students, so in this video, what I'm going to do is just go over the solutions for problems 1, 3, 4, and 11. So with number 1, you have this worm that's at the bottom of a 12-foot wall, and every day he crawls up 3 feet, but at night he slips down 2 feet, and then he starts at that same place and continues the same pattern until he gets to the top of the wall. And we want to know how many days it takes for him to get to the top. So this is a drawing I created for this. I'm going to kind of use my cursor to illustrate what I did. So day 1, the start of day 1, he goes up 3 and then he comes back 2. So this is where he is at the end of day 1, also the beginning of day 2. Day 2, he ascends 3 and then comes back down 2. Here's where he is at the end of day 2, but also the beginning of day 3. This pattern continues. And what initially you may see is like, oh, at the end of every day, he is at that day's value feet-wise. So at the end of day 4, he's at 4 feet, end of day 5 at 5 feet, end of day 6, 6 feet. And so you might assume, oh, okay, so it's going to take, ever so many days, 13 days then to get to the top, or 12 days rather to get to the top. But here's the deal. You have to remember that during the day he's ascending 3 and then at night he falls down. And it's a possibility then that in the process of ascending 3 coming back down 2, he hits the top before he descends. And that is in fact what happens. So let's come up here as we're going through this pattern. On the end of day 8, at the beginning of day 9, he starts at 8 feet and he goes up to 11, but then he falls back down 2. So at the end of day 9, he is at 9 feet. Then at the beginning of day 10, he gets all the way up to the top of the wall, 12 feet, before he has a chance to fall down. So at day 10, he gets to the top before slipping down. So it takes 10 days for him to get to the top of that wall. Okay, question 3 says a ball rebounds 1/2 the height from which it is dropped. The ball is dropped from a height of 160 feet and keeps on bouncing. What is the total vertical distance the ball will travel from the moment it is dropped to the moment it hits the floor for the 5th time? Okay, so when it initially dropped, it's going to travel 160 feet, but then it bounces back up and comes down. That would be the 2nd time it hits the floor. So before it hits the floor 2nd time, it's traveled 80 up and 80 down. So that'll be 2 times 180. That's 2nd time it's hit the floor. Before it hits the 3rd time, it'll go back up 40 and down 40, rebounding half of its previous length. And then before it hits the 4th, it'll go up 20, come down 20. And then before it hits the 5th time, it'll go up 10, down 10. So that's the critical piece here, that you're realizing you're covering those distances twice because of the rebound before it hits the ground again. So we add all of those distances up and we get 460 feet. Okay, for number 4. Number 4 is a little bit weird insofar as I don't feel like a diagram is the most expedient way to do it. So I didn't do one, which I should have, and I'm sorry I didn't. I wouldn't ask a question like this on the test because I don't think that a diagram was really the most expedient, but if you did one, you are awesome and you can show me what you did and that will help me to grow when we meet again. So number 4 said, how many 9-inch square floor tiles are needed to cover a rectangular floor that measures 12 feet by 15 feet? You ought to automatically realize you have 2 different units going on, so we need to convert one to the other. I always tend to do that bigger to the smaller one, that way I'm not working with decimals. So I need to convert 12 feet by 15 feet. Each of those 2 inches respectively, if I just tried to convert their product, I would miss the fact that it's feet squared and would probably underestimate, definitely would underestimate the number of square inches. So 12 feet times 12 will give me 144 inches. 15 feet times 12 give me 180 inches. The area of those together is 25,920 square inches. Now, you could do a drawing where you had 12 feet by 15 feet and then really indicate quite small that a 9-inch by 9-inch tile is a very small portion of that, to realize that you would need something much larger. In fact, 81 square inches in order to fit within that. So all we do is we would then take our total square inches, divide it by the square inches of the tile. They're 9 by 9, so we have to divide by 81, and that would give us 320 tiles. Again, you could draw it to show, and this would be particularly valuable to students who need to really recognize just how small the inches are when you're talking about feet, that those 9 inches have to be converted to, or that they really represent an 81 square foot tile, but within this very large space when converted to inches. Okay, the last one. It brings up some refresher of geometry. It says, in Amanda and Emily's apartment, a round table is shoved into the corner of the room. That round portion is critical. If it's round, it's a circle. The table touches the two walls at points that are 17 inches apart. How far is the center of the table from the corner? Please excuse my drawing. You all know how horrible I am at drawing. And I've got all these crazy kids running around now since they're all being homeschooled. So I drew a really crappy circle, but we're going to pretend it's a circle. Those two places where that circle hits the walls, which are indicated by those two perpendicular lines, they're 17 inches apart. So I drew a solid 17-inch line. Now they want to know how far away the corner of this room is from the center of the table. I can draw that to the center, but what I did first is I drew radii from this point where the table's hitting and this point to the center. Why did I do that? Because if this is a circle and these are both radii, then their values are x and x, meaning that this entire shape right here is a square. That's critical. If that entire shape is a square, then this 17-inch diagonal is also going to be 17 inches when you draw the diagonal from the corner of the room to the center. So the diagonals are the same since it's a square, and so what I'm calling y, which is that distance here, would also be 17 inches, and that is your answer. So now what you'll want to do is you'll want to move on and try what I call the homework problems. These problems that I just went over would be ones that we would have done in class together. We would have put them up on the board. So in order just to keep reinforcing your skills here, I'd like you to try the homework problems, and then I will put up some pictorial solutions for those at the beginning of next week so you can try them.